Welcome, life science learners, to another installment on scientific methodology. Today, we're going to look at how we represent data in a scientific experiment. Let's reflect on what we've done over the past couple lessons. So previously, we looked at scientific method, where we've discussed how to set up an experiment, how to identify different variables, how to look at controlling an experiment in terms of ensuring that it is a fair test. Today, we're looking at what happens when we've conducted an experiment and we've collected that raw data. Let's look at how we represent that data. Representing data is very important because if you do not know how to represent the data, you're not able to see the trends, you're not able to extrapolate or draw inferences and conclusions from that. So in science, representing data is crucial for scientists to be able to see trends, for us to be able to draw inferences from it. So it's quite an intricate science in terms of how we represent data. So let's get straight into that and look at how we represent data. So guys, if we think about data, have you ever thought about the following? Whether you're the world's greatest detective trying to crack a case or a person trying to solve a problem at work, you're going to need information. You're going to look at facts and data, as Sherlock Holmes would have said. So we're constantly surrounded by data, information, visual, stimulus that come in. And that information is being processed. When conducting an experiment, there's lots of information that we see. So there's different types of data that we can establish. So let's look at how we look at data, how we interpret that data, and how we present that data. So as we're going to look at in today's lessons, we've got to discuss what is data. We've got to look at what are quantities of data, how information can give us data, how information is presented in the form of graphs, how measurements are important to establishing data correctly, how when observing experiments that data can be generated, looking at facts that are available as information that supports data, and looking at how numbers can all give you data. So data is present everywhere. It's how we use that data in an experiment and present that information that's important. So some key words in today's lesson would be, as I mentioned, the word data. We've looked at variables in the past, and we know that there are three different types of variables: the dependent variable, the independent variable, and the controlled or the constant variables. And so we've unpacked these, and we'll talk more about these as we get into the lesson. We also need to look at how data is represented using line graphs, a bar graph, a histogram, pie charts, how that information is analyzed, how conclusions are drawn, to look at the relationship between variables, the concepts of interpolating and extrapolating information. So those are key words that will be used in our lesson today. So let's try and understand what is data or data. Data are units of information. Data can be collected on any topic and for any purpose, meaning that it is used in everything from scientific research and finance to business, management, and retail. So we are constantly supporting information. The fact that you walk into a mall, there's data around the number of people that move into that mall. You use your phone, there's information around the number of times you've used your phone. Google can track data, and that data talks about information that they can use to help retailers. The fact that when you write a test at school, that data is collected and it's used to generate a promotion mark at the end of the year, that is presenting the data. Your report that you get at the end of the year is data that's consolidated and presented together to determine whether you've passed or failed or how well you've done. So we've got to look at, in science, how we present that data and draw conclusions from that. So in schools, data is often collected, as I said, in science, in maths, through investigations. Importantly, there are two main types of data, and we refer to them as qualitative and quantitative. And let's pause at this moment. Let's try and understand the word quantity and quality. And if you unpack the words quality, it refers to the properties of things. So when you describe the color of something, the texture, the number of bubbles, those are describing the quality of a result. So if there's a dark color, if there's an intense precipitate that's formed, that is the quality of the results. However, you also can measure substances, you can measure quantities. So those quantities that are measured are quantifiable, meaning we can put a number to that. So that the length, the size, the height, the width, the time it takes, the amount of rainfall, those are all measurable data. And we refer to that as quantitative, meaning quantities. So let's try and unpack that a little further. So quantitative data deals with numbers and things that can be measured objectively. Dimensions such as height, width, and length are all quantities. Temperature and humidity, prices, area and volume are all quantities that can be measured, and we refer to these as quantitative measurables. And that often gives us quantities around specific dependent variables. We also have, as I mentioned, qualitative data, and this deals with characteristics and descriptions that can't be easily measured but can be observed subjectively, such as the smell of something, the taste, the texture, the attractiveness, and the color. So in science, we often rely on things and observations around the rate of a reaction by looking at the amount of gas, by looking at the number of bubbles that are produced, by looking at the amount of products. So if you can physically see a property and you're able to determine from that if the reaction is occurring or not, or if the products are being produced, we refer to that as being a qualitative result. And we'll talk about the differences of these in terms of the reliability in a scientific investigation when we measure these. How is data collected? Data collection is a process of gathering and measuring information on variables of interest in a systemic fashion, which enables one to answer stated research questions or to test a hypothesis. This can be done through the following: through doing a survey, through polls, having an interview with an individual, having focus group discussions, looking at observations, and carrying out experiments. So if you were to go around and if you were to do a census, which is counting the number of people in a country, that would be done through a survey. A survey would go around and you'll collect information through questions that individuals would answer. So that gives us information, and that information talks to the number of people in the country and their income, the literacy rate, the number of dependents, the education rate. That's the survey. We also do polls, and you would see that when you're watching the elections, you will see the polls, you will see the number of voters that have voted for someone, and that's often counting the number of individuals voting. So we refer to that as polls. One-to-one interviews. So if you were being interviewed by your peers around how you use water and the amount of water that you spend, or what mode of transport, in terms of trying to establish your impact on the environment, that would be an interview. And interviews often give you information that can be presented graphically, but also can be processed together to give you a better understanding around a specific measurable. We also know that there are focus group discussions where an interviewer would get information from a few individuals around a specific topic. So we have focus group discussions. We also have observations that can be made by looking at how things take place. So when you see an experiment taking place, and if you notice that there are bubbles, or if you can feel the texture, or if you can look at the quantity or the shape or the size of something, then that is an observation that you're making around a physical property. As we also mentioned, that there are experiments that generate numerical or quantitative data that can be recorded. So these are the different ways in which data can be collected. Let's look most importantly how data is presented. And often the best way to present data is in tables, where we group the data and we process that information so that we can present that information in a way that it's easier to read or it's easier to understand. So collecting the information is important, but presenting that information in a manner that's illustrative, that is easier to see trends, is important to the researcher. So we refer to that as the presentation of data. A table is a grid consisting of horizontal rows and vertical columns. This gives us a useful way to display information that needs to be compared. So often at school you would be referred to draw a table of your observations. Why do we do that? It's important for us to be able to do that so that we can present that information to see the patterns. And often a table is used to be able to convert that information into a graph. And so presenting information in tables is important in processing that information. So there are really two types of tables. The first type of table is for entering the measured data. We call that a quantitative data, which can then be used to construct a graph. The second type of table is used for comparing the non-numerical information, such as the properties which I mentioned earlier around the smell, the taste, the color, the texture. These are called, when we refer to them as qualitative data. Okay, so we're going to need to look at how we draw tables and record that information. So yes, you've drawn tables before, but it's important to follow a system. So generally, tables go down the page. The independent variable must be on the first column and clearly labeled. The dependent variable must be in the second column with headings. They should be row headings showing the characteristics that are being compared if it is appropriate. They should be units, which is the quantity being measured. And these units must only be in the heading and not in the body of the table. So we put that into the heading. No units in the body of the table. Okay, so before we get into a break, guys, here's an example of a table. Clearly I've given you a table heading. I've got clearly the columns as you see. I've got columns going down. I've got rows, and each of these columns have a heading. So here we've measured the grasshopper's mass, and we've looked at the length of these grasshoppers, and we've recorded that for 5 different grasshoppers. So clearly here we're recording the different grasshopper, and we're recording their lengths, and as I mentioned, we've got to indicate the units in only the heading of the columns. We've also recorded the mass of these, and I've indicated that here. And I've prepared that in a table where I have complete borders that are clearly outlined, and I've given this table a clear heading. So in short, we've presented information around 5 different grasshoppers that have been measured, their lengths, their mass, in a table that makes that information more accessible, easier to look at. And so we've looked at how we present that information in a table. So guys, you've done well. We've looked at presenting information now. Let's look at how we present that information in a graph or different types of graphs when we get back after a short break. So refreshen up, and I'll see you in a little while.